Hey guys, welcome to EduKaji. If you guys are first time here, allow me to introduce myself. So my name is Walter and I'm a chemistry tutor as well as a real life scientist. So this particular video will be discussing about a past trial paper for the SPM Chemistry syllabus. So without further ado, let's jump right into it.
Hello guys, so this is the Perlis past trial paper. Okay, this is the Perlis past trial paper for year 2022 for the chemistry paper 1. So without further ado, let's take a look at the questions together. So the first question here, which of the following processes physical change from liquid to gas? So when talking about from liquid to gas, it can mean quite a number of things. In this case, it can be actually evaporation. It can also be boiling as well. So those are technically the possible answers that can be given. Okay. So then the answer is going to be B. Okay. Because boiling and evaporation can both happen when the liquid changes into gas. For number 2, which of the following is use of the isotope iodine-131? So usually iodine-131 is associated to your thyroid gland. So I think the answer for number 2 here is very clear. The answer is A. It's used to treat thyroid gland cancer. Okay. For number 3, which of the following is the correct pair of compounds and its chemical formula? So for chemical formula over here, sodium oxide. So sodium is a +1 and the oxide is a +2. Sorry, -2. So if you were to take the formula, right, Na plus and O2 minus, if you cross them, you should be able to get Na2O. So supposedly this is 1, this is 2, do the crossing method. The correct formula is supposed to be Na2O, okay, Na2O. So this is supposed to be the answer. So this is wrong. For potassium chloride, K is plus and Cl is minus. So it's a 1-to-1 ratio. So therefore, there's no need to cross. The formula is supposed to be KCl. And then for copper 2 nitrate, it's supposed to be Cu2 plus and also NO3 minus. So it's a +2 and -1, you should cross. So your subsequent formula should be Cu NO3 2. Okay, so again, this is also wrong. So we got 3 wrongs, and the last one's probably going to be correct. For D, lead-2 chloride. So Pb is 2 plus and Cl is minus. So it's going to be a +2 and -1. If you cross, you get PbCl2. So this is technically correct. For number 4, which of the following gases is used in the weather balloon? So weather balloon is usually we use helium gas because it is actually less dense than air, so you can actually float to the top. So therefore, the answer here will be helium. While the rest of them are actually quite heavy, so therefore it's not suitable for them to float on air. Therefore, cannot be used as a weather balloon. Then for number 5, what type of chemical bond in water molecules? So in the water molecules, right, we have those molecules that there are forces in between the molecules and also within the molecule itself. So if you talk about within the molecule, then it will be covalent bond, because within means they're referring to the chemical bond between the oxygen and hydrogen atoms. So that is referring to covalent bond. Okay. While the other one will be, if this case is like, for example, if the hydrogen were to be close to the oxygen from another water molecule, then therefore this one here will be called as the hydrogen bonding. So in this case here, they say inside water molecule. So in means it's like within the molecule itself. So we wouldn't call that as hydrogen bonding. And plus, if you see the options that's given to you, none of them are actually hydrogen bond. So therefore, they're not referring to the intermolecular force, but rather the force that is pulling the atoms together. So therefore, the answer should be covalent bond instead. For number 6, which of the statement is correct about metallic bond? Metallic bonding is usually when you have the ions of the metal, when they are arranged together, okay, in a regular manner or regular structure. So what will happen here is, let me just draw that again. Okay, so you can see that the positively charged ions are actually surrounded by electrons that's moving throughout the whole structure, those delocalized electrons. So that is the basis of metallic bonding. And the ions are not attracted to each other technically. They are actually attracted towards the electrons that's circulating around the ions. So I think the only possible answer that describes this metallic bonding is that the answer is D. The electrostatic force between the sea of electrons and a positively charged metal ion is referring to the metallic bonding, okay? So as long as you have a positively charged particle, okay, attracted towards a negatively charged particle, it can be ion and ion, it can be also ion and electron, no problem, right? Because they're all different charges. So if you have opposing charges, right, any particles with opposite charges, when they are attracted to each other, we consider that as electrostatic force. So the answer here will be donkey. For number 7, which of the following particles in solution of ammonia is responsible for its alkaline properties? And no matter what happens, right, remember this, acid will always be able to produce hydrogen ions, and that shows acidic properties. For ammonia or any bases or alkaline solution, to show an alkaline property, you must have hydroxide ion, okay? So the answer will be OH minus. Always remember that acid is always hydrogen ion, and alkaline solution or alkaline substances will always be OH minus or hydroxide ion. The fact that ammonia can dissolve in water to give you ammonium ion, it also proves to you that the hydroxide is also produced. For example, if you were to dissolve, okay, or to ionize ammonia in water, because ammonia is actually soluble in water, then subsequently what you'll have is partial dissociation of the substance to produce NH4 plus as well as OH minus. So therefore, the hydroxide ion is produced in this manner, and the hydroxide ion is basically the one that shows the alkaline properties. Same goes for any other bases. For example, you have sodium hydroxide, which can then undergo dissociation in water to produce Na plus and also OH minus. So that I can actually give you an idea that, you know, you technically have the OH minus as the source of alkaline properties. Let's move on to 8. Which of the following is not a chemical property of acid? Chemical properties referring to the type of chemical reactions that it can carry out. Okay, chemical properties usually means chemical reaction. So let's look at A. React with base to produce salt and hydrogen gas. This is actually salt and water actually. So this is actually wrong. So usually we say, right, for example, sodium hydroxide plus HCl, you'll get like NaCl plus H2O. So NaCl is actually a salt and water is being produced at the same time. So usually neutralization reaction between a base and an acid, they will always be able to produce a salt and water. But since this question actually told you that it says here, able to produce hydrogen gas, then therefore I don't think that's correct really, okay? So number 8 is actually A is wrong because it's asked for not ma. So confirm A is the answer really. So if you look at the rest is about correct. B, C, D, they're all correct. Like for example, metal oxide to produce salt and water, that's true. Okay, so acids do react with metal oxide to produce salt and water. For example, you can take copper oxide, let's just say you take magnesium oxide and you react it with sulfuric acid. So alkaline oxide can react with acid and you will get, for example, magnesium sulfate, and also water being produced. So that's the basis of the reaction B, and therefore this is considered as correct. Reactive metal can produce salt and water, salt and hydrogen gas. Yes. So for example, if you were to take H2SO4, right? Sulfuric acid again, react with zinc, you'll be able to get zinc sulfate and also hydrogen gas. So this also proves to you that this is actually correct. And D, react with metal carbonate to produce salt, carbon dioxide, and water. This is also true. For example, if I use back the same acid, sulfuric acid to react with calcium carbonate, you'll be able to get calcium sulfate as a salt, plus carbon dioxide, plus water also. So technically speaking, D is also possible. So the only one that's not possible should be A lah. So that's why the answer is A, because it says not a chemical property. Yeah. Let's go to number 9. Name a gas that turns lime water cloudy. So when you talk about lime water tests, since your PT3 level, you also know that technically carbon dioxide is the one that can produce, can turn lime water cloudy. Okay. So the basis of the reaction is very simple. Okay. Why lime water can turn cloudy in the presence of carbon dioxide? That's because carbon dioxide is an acidic gas. And technically speaking, lime water is not your limau ice. It is actually your calcium hydroxide. So if you were to react carbon dioxide, which is acidic, with a base such as calcium hydroxide, you'll be able to produce calcium carbonate, which is a type of insoluble salt, and you'll be able to produce water as well. So therefore, you'll be able to see that, okay, no matter what happens here, you'll technically have calcium carbonate being produced. And because calcium carbonate does not solubilize in water, it is a non-soluble salt. So therefore, then you'll be able to float or precipitate out onto the inside the beaker, technically. Then you'll be able to see that there'll be a cloudy mixture being formed. So the cloudy mixture is actually the calcium carbonate unable to dissolve in water, so it remains as a precipitate. So therefore, the answer is C. Number 10, which of the following is not the unit for rate of reaction? So rate of reaction is the change of product or amount of reactants per unit of time. So I think you see properly, right? Every single unit there got like mass and time, there is volume and time. But the last one is not. Last one is mole per dm cube, and that's basically referring to concentration or molarity of a solution. So therefore, that is not the unit for rate of reaction. Well, the rest is because it's either change in mass or volume of product over time. So got every single part of time there, but except for D. So D is not the answer. 11, which of the following substances is the main component for glass? So glass is actually sand, and sand is apparently silicon dioxide. So therefore, the answer is board. 12, the following equation shows the reaction between copper 2 oxide and hydrogen gas. So what is the type of reaction that takes place in copper 2 oxide? I think we see closely, right? Copper actually loses its oxygen to water. Copper oxide actually loses its oxygen to hydrogen, and copper is then reduced to pure copper oxide is then reduced to pure copper. So this is actually a redox reaction. Okay. So we see closely, it's asking you what is the type of reaction, okay, that takes place for copper 2 oxide. So copper 2 oxide losing its oxygen, forming just pure copper alone, will technically undergo a reduction process. And the fact that it loses its oxygen, right, and it reduces its oxidation number, that 2 points alone can prove that actually copper oxide undergoes a reduction process. While hydrogen itself gains the oxygen, so we'll say that hydrogen technically, undergoes oxidation process. So therefore, the answer for 12 is A. Which of the following is non-hydrocarbon? So hydrocarbon refers to what? Refers to compounds which contains carbon and hydrogen only. Okay, carbon and hydrogen only. So if you see properly, right, alcohol has a general formula of CnH2n plus 1 OH. While alkane, alkene, alkyne, if you see properly, they all have like only hydrogen and carbon. Okay, alkene, it'll be CnH2n, and alkyne will have CnH2n minus 2. Okay, so all of them have only carbon and hydrogen except for alcohol, in which you can see there's actually an O over there. So as long as you got any other elements present inside a compound besides carbon and hydrogen, then that particular substance is no longer called a hydrocarbon. It is another name instead. Hydrocarbons are exclusively used for compounds which contains only carbon and hydrogen atoms inside their molecule. So therefore, the answer here will be C. 14. Which of the following is not an endothermic reaction? The endothermic reaction means reactions that absorb heat from the surrounding. Okay, exothermic releases out, endothermic actually absorbs it in. So among all of these for number 14, I guess the answer is only neutralization, which is actually exothermic. If you remember back in your thermochemistry chapter from 5 chapter 3, you'll come across the heat of neutralization. You realize that one key point you must remember is that all neutralization reactions will be what we call as exothermic. Yes, sorry, I lost the word. Exothermic. So therefore, that's not an endothermic reaction, right? Not an endothermic reaction. So therefore, B is not endothermic because it is exothermic. Okay, 15. Which of the following describes a monomer? So a monomer is like the simplest form of a polymer. Simplest form means technically the smallest unit of a polymer. So therefore, I think the best description to describe what is a monomer for number 15 over here will be A, the repeating unit in a particular polymer. So that's how it looks like. 16. Which of the following are basic ingredients of cosmetics? So cosmetics are things that we normally use to put on our face. For example, like those powder or blush or anything that's related to your face or on your skin. We call them as cosmetics. Okay. So what do we need in the cosmetics and what are the basic ingredients? I think one of the basic ingredients that you need inside a particular cosmetic is that you need a moisturizer and an emulsifier. So usually moisturizer, because some of these ingredients, some of the cosmetic products may cause the skin to be quite dry. So in order for you to make sure that your skin does not dry up, all right, which will cause more problems later, is that they put in moisturizer to help you to make sure that your skin is remaining soft and hydrated. Okay, emulsifier is a substance that helps to emulsify the ingredients so they can mix well together. While the stabilizer and bleaching agent is not necessary. Yeah, okay, stabilizer and bleaching agent is not necessary. So the best answer here will be 1 and 2A. 17. Which of the following substances is made up of one atom only? Usually we look into pure metals or noble gases because it says here only one type of atom. Then they are only referring to what they're referring to, an element. Okay, air consists of many things, right? Carbon dioxide, oxygen, nitrogen. So this is actually a mixture. Iron itself is consisting of only a single substance, so it's an atom. For sure, right? And then naphthalene is a molecule. Water is also a molecule. So molecules and mixture will have more than one type of atom for sure. So therefore, the best answer here would be pure metal, such as iron, which has a single atom only inside the chemical structure. Number 18, which of the following particles equals to 1 mole? So 1 gram of hydrogen gas. So we'll say that hydrogen gas is H2. So if you want to calculate number of mole, okay, number of mole of 1 gram of H2, it will be 1 divided by 2. So therefore is 0.5 mole only. So therefore that's wrong. A is wrong. Number of molecules in 1 gram of hydrogen gas. So same thing, 1 gram of hydrogen gas is technically not enough. It's only 0.5 mole. So if you were to multiply it, also you get half only. So therefore B is also out. 6.02 times 10 to the power 23 atom of hydrogen in hydrogen gas. Hydrogen atoms in hydrogen gas. So for every one molecule of hydrogen gas, that's H2, right? So if you're talking about the atoms that's present, right, they will have twice the number of atoms. So actually, right, supposedly, C is supposed to be Avogadro's constant multiplied by the number of mole. Okay, then that should be correct. So C is also up, technically. Last one, 6.02 times 10 to the power 23 of hydrogen molecules in hydrogen gas. This is correct. Why? Because they're referring to molecules, not the gas itself, not the particles, not atoms. Okay, molecules of the gas. So therefore, you say one more of the gas, I should have one more molecules. Correct. Okay, so the answer here will be D. Number 19, diagram 1 shows the method used to store an element. Okay, that's paraffin oil. Usually it is used to contain, it is actually used to prevent water, okay, from going in or any amount of air going inside because it's very dangerous. Okay, so what kind of elements are usually kept like this? Normally, group 1 elements. Okay, group 1 elements because they are very and highly reactive. So I'll say that the best answer for number 19 over here will be C. All right, to prevent the element from reacting with air so it doesn't cause an explosion. Okay, especially group 1 metals. 20. In a periodic table element, X element has 11 protons while Y has 17 protons. So X has 11 and Y has 17. So what happens here is that we are supposed to describe which of the following is not true about element X and Y. So size of X is much bigger than Y. I think this is technically correct because when you go from left to right on the periodic table, the left side will have bigger size, and then as you gradually go towards the right side, the size of the atom actually decreases. Okay, so the best answer here, let's see, B. X atom is more electronegative than Y. This is wrong. Across the period, electronegativity will drop because they're getting more and more electronegative. Metals tend to be electropositive, but as you go along, more and more electrons need to be removed from the electron shell, the valence shell. So therefore, it's quite hard for them to actually do so. So in this case, B is definitely out. Oxide of element X is alkali. Oxide of Y element is acidic. Oh, sorry. Oxide of X is alkaline, while oxide of Y is acidic. So I will say that X is supposed to be alkaline, Y is supposed to be acidic. So they actually twisted it. Right? So this is actually wrong also. Okay, these two are wrong. And then the last one, the tendency of the release electron of X atom is higher than Y. Also, this is true. The ability to release electrons out is called electropositivity. So metals which are arranged higher tend to be more electropositive compared to what's it called? Compared to sorry, let me just repeat that again. Oxide of X is alkaline and oxide of Y acidic, correct? So X is on the left side, X first, then Y. I saw wrongly. Sorry. So actually C is also correct. Because X is located on the left side and then Y is on the right side. So X is supposed to be alkaline in nature, correct? Okay, so yeah, Y is supposed to be acidic. So therefore, that's my mistake. For D, tendency of the release electrons of X is higher than Y. So I will say in this case here, to release electrons means it must be more electropositive. Okay, so I will say that to release electrons, I think most likely X atom will be the suitable example. So this is technically correct also. Okay, because from left to right, electropositivity will drop, but on the left side, the metals are all very electropositive. Okay, so only 3 correct answers and 1 wrong, but since they want the not true version, so you can write the answer down straight away. Okay, so therefore the answer here will be boy. For question number 21, which of the following molecules share 3 pairs of electrons between 2 atoms? So I think this is very simple. The number of electrons that can be shared between 2 different atoms will depend on how many electrons they are lacking, all right, to achieve octet in this particular case. So between hydrogen and hydrogen, they only share one electron because technically speaking, hydrogen has only one valence electron. So they have to share each other with other one pair only to achieve stability. Oxygen will have to share two electrons to form a double covalent bond, and that will allow them to basically be able to achieve octet, right? And between chlorine is it has 7 valence electron, right? So they need to share one electron between each other, so they also form single covalent bond. Nitrogen is supposed to be the answer because nitrogen has technically 5 valence electron. It needs technically 3 more electrons to be shared among each other to achieve octet in this case. So therefore, the answer is supposed to be nitrogen. For number 22, which of the following substances dissolve in water to produce a solution with pH value more than 7? If it's a pH value more than 7, means it must be something of a alkaline characteristics. So in this case here, they say, the substance must be able to dissolve in water, right, to be able to produce a solution with a pH value of more than 7. So if it's more than 7, I would think most likely in this case, because more than 7 basically means as alkaline substance in this case, right? So for 22, I would say the answer is ammonia gas. Okay, ammonia gas can dissolve in water to produce a solution of ammonia consisting of ammonia, ammonium ion, and also hydroxide ion. So therefore, this is considered as the alkaline substance. Okay, so most likely you'll be wondering like why others cannot. So copper hydroxide over here cannot dissolve. I mean, it is already considered as a solution. Okay, and then magnesium hydroxide also considered as a solution already. So these two itself are already in a solution form. So therefore, they do not have to dissolve in water anymore. Carbon dioxide gas is actually acidic. So you should have a pH less than 7. So we all know that carbon dioxide dissolves in water to produce carbonic acid in a way. Okay, and it should be an acid. So it should be a lower pH than 7. So the only possible one that is according to this question will be A. 23 following equation represents a reaction between zinc metal and hydrochloric acid. So determine the maximum volume of hydrogen gas released when 50 cm³ of 1.0 mole per dm³ of hydrochloric acid reacts with excess zinc at room condition. So we have this equation, and to interpret it quantitatively, we'll say that 1 mole of zinc will need 2 moles of hydrochloric acid to produce 1 mole of zinc chloride and 1 mole of hydrogen gas. So right now, if we got the concentration of acid, let's compare number of moles. So in this case here, to get the number of mole of acid, we have to use the formula of mv over 1000. So in this case, it will be 1.0 times 50 divided by 1000. So the answer here will be 0.05 mole. Okay, so you can see here we're comparing for every 2 mole, you get 1 mole of this. So therefore, if you want to compare in terms of mole, right, if it's HCl to H2 ratio, it should be 2 to 1. So currently what we have is 0.05 mole. If you were to get half of it, it would be 0.05 divided by 2, and that should give you 0.025. So the number of mole of hydrogen in terms of comparing ratio, it will be 0.025 mole. So to get the maximum volume of hydrogen gas produced, will be 0.025 multiplied by 24 decimeter cube, because it says it is supposed to be in room condition. So therefore, you get 0.6 decimeter cube.
So therefore, the answer here should be A. Okay, let's move on to the next question. So this is number 23. Now we're going to number 24. Diagram 2 shows an experiment to produce salt P. So what we have is calcium nitrate reacting with zinc sulfate. And then after that, what we have is that you're supposed to get a salt being produced. So let's take a look at that. So what salt solution can be used to replace calcium nitrate solution to produce salt that can have the same solubility as P? So what happened here is that technically speaking, if you take a look at this particular question, the outcome of the experiment is that when you have calcium nitrate reacting with zinc sulfate, you'll get an insoluble salt of calcium sulfate and zinc nitrate will be produced. So the salt P that is being formed here is supposed to be a precipitate, and this is actually referring to calcium sulfate, right? Insoluble salt. So it's asking you, right, if you were to, if you want to replace the salt of calcium nitrate to something else, which will produce another insoluble salt, what would it be? So my answer here will be boiler. Why? Because copper, iron, and magnesium sulfate, all of them also can solubilize in water. I mean, if that's the possible outcome. So A, C, and D, technically speaking, there is no end result that will produce any precipitate if you were to add it with zinc sulfate. However, if you were to add lead nitrate, for example, okay, if you were to add lead nitrate in this case, together with zinc sulfate, you will end up with lead sulfate, which is also another form of an insoluble salt. And what will happen is that you will then get zinc nitrate as well. So both of these outcomes will produce a gas which is technically insoluble in water. That's why my choice here will be boiler. 25, when 2 cm cube of copper 2 sulfate solution is added to the mixture of dilute sulfuric acid and zinc granules, the rate of reaction increases. So which statement best explains why rate of reaction increases? So you say here, you add copper 2 sulfate solution inside the reaction where sulfuric acid is supposed to react with zinc. So we'll say that copper 2 sulfate here acts as a catalyst. Okay, so CuSO4 here is actually a catalyst. So what's the function of a catalyst? That's the question, right? The function of the catalyst is actually to provide the reaction with an alternative pathway of a lower activation energy for the particles to collide more easily, in a sense that they will technically achieve more effective collisions in this case. So therefore, I think the answer for 25 over here, the best answer will be C, to increase the effective collision frequency so that more product can be formed in a shorter period of time. Okay, now it does not increase the number of frequency because the catalyst doesn't actually interrupt the reaction, but rather it provides an alternative pathway of a lower activation energy so that the reaction can proceed forward in a much faster rate. So diagram 3 shows the reaction between zinc and nitric acid. So zinc plus nitric acid will technically give you a hydrogen gas being produced, and then you will get zinc nitrate as your main substance. So which of the following is a measurable change in this reaction? So it depends on what you see. So I think that over time, you will be able to see zinc will dissolve for sure because it's reacting with the acid. And number 2, you can see gas bubbles are being produced. So I think the thing that you can measure here will be very simple, either a decrease in mass, all right, because you can see, right, the amount of gas that's forming will eventually evaporate away. So the total mass in the system will decrease, it will drop. So mass will definitely decrease. And the second one will be hydrogen gas or bubbles will be formed over time. And that actually allows you to measure the rate of reaction. So for question number 26 over here, the best answer is actually donkey, right? Where I said that to measure the rate of reaction, you can either see gas bubbles being produced and can be collected, or the amount of zinc that dissolves, and eventually the mass will decrease. So none of that actually increase, none of A, B, C indicates that A, decrease in volume of hydrogen gas is wrong, because we know that over time we have more and more gas being produced.
increase in mass of zinc is impossible because zinc is actually reacting with the acid. So the amount of zinc should be reduced and the volume of nitric acid will not be decreased. The amount of solution is still the same. The water is present there. So therefore, I think C is not the right answer as well. So the best answer to describe the situation over here will be the gas bubbles being produced. And that is actually your H2. So based on what you have in the H2 itself, we will know that over time, the amount of hydrogen gas will definitely increase. Therefore, donkey. 27, diagram 4 shows a bridge of for the pedestrian. One company in China used steel to construct a bridge, which of the following is the arrangement of atoms in steel. Steel itself is actually an alloy. All right, we're referring to an alloy. And this alloy is normally very strong and resistant towards corrosion. So if you see everything properly, I think you must be able to recognize what steel is actually made of. So if you see properly over here, all right, definitely for number 27 here will be, let's see. I think it's most likely B because steel is made out of iron and carbon, right? So iron and carbon. If you ask me like, why is it not donkey then, for example, right? We know for sure copper and zinc is not the main substance for the steel because the main composition of steel, right? The main composition of steel is iron. Iron is the main constituent. So A and C here has no iron at all inside, so therefore it cannot be steel anymore. But you can see over here, what about donkey then? Nickel, iron, and also carbon, right? Can it be also steel? D is referring to stainless steel, actually. There's a difference between normal steel and stainless steel. Stainless steel is the one that we use to make like cooking appliances, cooking utensils, all right, which actually expose themselves most of the time to water. Then they will rust, isn't it? So by using stainless steel, you won't be able to rust. However, just pure carbon and alone, pure carbon and iron mixed together, that will give you technically steel, just normal steel. We don't want stainless steel, okay? It's quite expensive to use stainless steel to build bridges, all right? And usually you can see that normal bridges that we have, they normally rust quite easily as well. Like over the many years, you'll just rust. If it's stainless steel, then it won't rust at all, right? But the cost is expensive, it's hard to get. So therefore, most likely it is just pure steel. Steel is just carbon and iron. So 27 is point. Let's go number 28. So which of the following solutions should not be stored in tin plate container? The answer is supposed to be silver nitrate and copper sulfate. The reason why is because if you see, tin itself is actually higher in terms of its position in the reactivity series. So if you were to mix tin with silver nitrate, for example, okay, so what will happen is that tin itself will then dissolve, right? Tin will dissolve and it will then reduce the silver nitrate into pure silver. So you'll form tin nitrate and then you'll form pure silver instead. So this means that your tin itself will corrode. It will corrode and then it will spoil the container. And same goes for copper 2 sulfate because tin is also more reactive than copper. So what will happen is that when you mix tin with copper 2 sulfate, the same thing happens. You will get tin sulfate and you will get just pure copper. So again, once again, you'll see that the tin will actually dissolve, okay, into the solution and then copper metal will be formed. If you were to mix it with the first two, which is sodium nitrate and potassium chloride, nothing happens. All right, nothing happens because in this case, sodium and potassium itself will not be able to corrode the tin plate. Instead, they're supposed to act as a sacrificial metal if they are pure substances, but it is not, right? So there's no reaction between tin plated container with the sodium nitrate and also potassium chloride. So this 2 is a no. So therefore, the answer is 3 and 4, and the answer is donkey. 29. The unnatural smell of pineapple is due to the presence of an ester, which is the following is the name of the ester. So if you want to talk about pineapple's flavor or pineapple fragrance that comes from the flavoring agent is supposed to be ethyl butanoate, okay? Something that you must memorize from your textbook, okay? Go and look up for your textbook or your reference books. You'll be able to notice that pineapple is actually one of the very common types of flavoring agents. And the answer here is ethyl butanoate.
Number 30. The following represents the formation of magnesium sulfate. Heat release when 1 mole of magnesium sulfate is 467 kilojoules per mole. All right. So in this case here, they're asking you which energy level diagram is correct. So if you see properly, right, it says here heat is released. So when heat is released means it is actually an indication that it is an exothermic reaction. Okay, exothermic reaction. So right now, if you see this question, right, this 2 is wrong already, because if the arrow is pointing upwards, that means that it is actually an endothermic reaction. It doesn't matter the negative symbol is here, but the arrow is supposed to point down to form the exothermic reaction. So A and B is definitely out. Now left C and D, okay, and like I said before, it must be pointing towards downwards, so the arrow is correct. However, we know that exothermic reaction has a negative delta H value, so this is definitely out already, okay. Only this one has a negative delta H value. So negative delta H value plus the arrow pointing downwards indicates that C is technically the answer to represent this reaction, which is an exothermic reaction. 31. Which chemical reaction produces the highest heat on neutralization? So highest heat on neutralization, right, is usually arise from technically using strong acid plus strong alkali. Why? Because if you see properly, right, strong acid and strong alkali will have highest amount of H plus and OH minus to form water. The idea is that the heat of neutralization is all about how much water molecule is formed from the H plus and OH minus. Okay, so the more H plus and the more OH minus, the better, and the more heat is being released to the surrounding. So you have to choose strong acid and strong alkali because they dissociate completely in water to produce high concentration of H plus and OH minus. So among the list you can see here, there's only one possible answer, and that's basically C, because that's the only one that has a strong acid, which is sulfuric acid, and a strong alkaline solution, which is sodium hydroxide, to produce sodium sulfate and also water. Therefore, the answer here will be C. 32. Diagram 5 shows the polymerization reaction of substance P to form substance Q. So P and Q are similar in terms of what? Okay, so right now P is ethene and Q is polyethene. All right, one is a polymer and one is also a monomer. So if you ask me what is similar in terms of these two structures between ethene and the polymer polyethene, I would say it's definitely percentage of composition. Okay, their ratio will always be the same in terms of number of carbon atoms and also hydrogen atoms, because the amount of monomers that you use will correspond to the mass of the polymer as well. So the percentage of composition should not change in this case. 33. Diagram 6 shows the structural formula of a polymer. Okay, what is the relative molecular mass of the monomer in this polymer? So the monomer is something that you must find out first. And if you see, we are trying to look out for the repetitive unit over here. If you see properly, right, the bottom is all H, the middle is all C. The only difference that you see over here is the alternate forms of this H and Cl, HCl, HCl. So we want to find out just one subunit of the polymer. You can just draw lines over here to show that these three structures are technically identical, which tells you that the monomer is actually supposed to be a double bond between C, and then you got a H over here, and you got a Cl over here, and then you got another 2H at the bottom over here. So this is the original monomer. So original monomer over here is supposed to calculate the relative molecular mass, right, of this particular monomer. So right now you got 2 times carbon, 3 times hydrogen, and 1 times chlorine. So that will be 2 times 12, which is 24. This will be 3 times 1, so this is 3, and this is 3. Sorry, this will be 1 times 35.5, so there will be 35.5. So if you add all three together, let's see what we get. 24 plus 3 plus 35.5. So your answer here is supposed to be 62.5. So therefore, the relative molecular mass of this particular substance should be 62.5. Therefore, the answer is A. 34. The following shows a conversation between Raju and Farhan during camping near the seaside.
For my clothes still have blood stains, although they have been washed twice in the seawater. And Farhan says, try washing them with cleaning agent, blood stains cannot be removed. Oh, sorry, blood stains could be removed. Which of the following cleaning agents can be used by Raju to determine and see what is the best one to be used to cleanse the clothes? Okay. So I think most likely the stubborn stain, which the blood itself has a lot of protein and also a lot of iron inside. So what you can use to wash away blood stains is actually detergent that can degrade off proteins, for example. So I think detergent that contains biological enzymes is the best in terms of removing that stain. I think some of you will actually argue and say that, what about sodium hypochlorite, which is bleach over here? Isn't bleach better? So it depends on what kind of clothes the person is wearing. Now, most of the time, we don't want to have bleach onto our colored clothes, because if that's the case, then you'll produce patches, it will decolorize your shirt, which you don't want that. So the best one is to try with detergent with biological enzymes, which can then help to remove that particular blood stains much more easily. Okay, so number 34 is 8. 35, diagram 7 shows the reaction of acid X. So here, acid X reacts with iron powder to get iron 3 nitrate, and acid X reacts with zinc carbonate to form salt Y. So I think very simple. Technically, for iron itself, reacting with a particular acid to produce a nitrate salt. So it must, in this case, acid X should be HNO3, all right, which is nitric acid, because you know that if, for example, if you see iron hydrochloric acid, sorry, nitric acid reacting with iron nitrate. In this case, it will be iron 2 nitrate. Will technically give you, hey, where's the iron powder to get iron nitrate? Sorry, I'm a bit confused. So then what you'll get is very simple. You'll get iron nitrate, right, which is FeNO3. Plus H2. So that's why you can confirm the identity of the acid as nitric acid. And then nitric acid reacting with zinc carbonate. So what will happen is that you'll produce zinc nitrate as a salt, which is ZnNO32 plus CO2 plus H2O. Then you will see that this is actually possible. So the salt that's being formed, or salt Y, is technically zinc nitrate. So therefore, the answer here will be cat. All right, for 36, table 1 shows the number of volume of oxygen liberated at regular time intervals for the decomposition of hydrogen peroxide at room temperature catalyzed by manganese 4 oxide. So the volume of gas produced over time will be in that table. It shows you there, right? So it's asking what is the average rate of reaction in the 3rd minute. So in the 3rd minute means you have to check average reaction in the 3rd minute. So that will be the 3rd one, deduct the 2nd one. So therefore, for number 36 over here, it will be rate is equivalent to 25.7 minus 17.6 cm cubed divided by 3 minus 2 minutes. Okay, so it's 3 minus 2 minutes. So we double check, let me see what it is. So it's 25.7 minus 17.6. That should technically give you 7.8 divided by 1. And then your answer should be 7.8. Oh, sorry. Wrong, miscalculated, sorry. 25.7 minus 17.6, which will be 8.1, sorry. So 8.1 divided by 1. So it's definitely going to be 8.1 cm cubed per minute.
So therefore, the answer here will be boy. So whenever I say in the, right, the keyword here is in the means between 2 and 3. So you have to take the 3 and then minus the 2. Or should I say the particular data, deduct the previous one to get your answer. 37, the following equation represents the oxidation of iron by steam. What is the maximum mass of iron 3 oxide produced when 50 grams of steam reacts with 100 grams of iron? Okay, let's just see how much we have in terms of number of mole. Steam is referring to water. Okay. So right now, water H2O has the MR of 18, and the iron is AR, AR will be 56. Okay. So number of mole of H2O will be 50 divided by 18. You get 2.78. And after that, for the iron, it will be 100 divided by 56. We should get 1.79 more. Okay. So in terms of water to iron, we'll see which one is in excess actually. Yeah. So for every 3 moles of water, you need 2 mole of Fe lah. Okay. So right now you must see whether 1.79 is actually exactly half of 2.78 or not. Oh, sorry, the ratio must be 3 to 2. So 3 to 2 lah. The ratio of water and iron must be 3 to 2. So you must see whether you got 3 to 2 or not. So 2.7 divide by 3, which is 0.9267 multiplied by 2. So that'll be 1.85. Okay, so one more time. Supposedly your ratio in terms of 2.78 if you were to divide by 3 times 2 to get the ratio, you will technically need 1.853. Okay, you need 1.853. So the question now is, do we have 1.853 more? No, we don't have. Why? Because the only amount we have is actually 1.79. So that tells you that water is actually in excess. So we cannot take the number of mole of water as a reference. Instead, we need to take a limiting factor. Currently, the limiting factor is this. All right, this is your limiting factor. So we can only react as much as that, and that's it. The one in excess will be in excess, no choice. So this is the limiting factor. So always follow the limiting factor, not the one in excess. So then we'll follow the number of mole of iron instead, which is 1.79. So if you see this question alone, right? Iron oxide number of mole is half of Fe. So since we've got 1.79 mole, right? We have to divide by half. Okay. So therefore, we'll say that number of mole of Fe2O3 will be 1.79 times 2. No, sorry, divide by half. Divide by 2, not times. 1.79 divided by 2. So the answer is supposed to be 0.895. Okay. So this is the number of mole of iron 3 oxide. So right now, to calculate the mass of iron 3 oxide produced, we have to calculate the molecular mass of Fe2O3. If you follow the information given, it'll be 56 times 2 plus 16 times 3. which will give you a total of 160. Okay, so the molecular mass of iron 3 oxide will be 160. We got 0.895 mole of iron oxide. So therefore, it will be the mass of iron oxide will be 0.895 multiplied by 160. The answer should be 143.2 grams, which is now going to be kept. All right, 38. 110 grams of propane gas undergoes complete combustion and excess oxygen. What is the volume of carbon dioxide gas produced at room condition? Should be easy. So when you combust hydrocarbon gases in excess oxygen, you will get only carbon dioxide and water. So we got 3 carbons over there, we got 4 oxygen. So total number of oxygen will be 4 plus 6, which is technically 10. So this would be 5. Right, so that's the equation, complete equation. So for every 1 mole of propane, you will get 3 moles of carbon dioxide gas. So right now, the first thing to do is to calculate number of mole of propane. So the first thing to do now is to calculate the mass. So the mass over here will be 110 grams divided by the MR. So MR will be 3 times 12 plus 8. So it'll be 44. Okay. So the answer now will be 2.5 mole. So number of mole of C3H8 is actually 2.5 mole. You can see that for every 1, you will need 3. Right? For every 1 mole of propane, you get 3 moles of carbon dioxide gas. So number of mole of carbon dioxide gas will be 3 times than that. Okay. So between C3H8 to CO2, it will be 1:3 ratio. So that will be 2.5 to 7.5. So now the number of mole of carbon dioxide is 7.5. So volume now will be 7.5 multiplied by 24 dm cube per mole at room conditions. That will be 180 dm cube of gas collected exactly. So therefore, the answer here will be donkey. So we got the diagram over here that shows you a polystyrene cup with substances reacting in the inside. Then you have to stir it using the thermometer, and you can see that there's an increase in temperature from 28 to 31.0 degrees Celsius. So diagram A shows an experiment to determine the heat of precipitation. So apparently this too is a soluble salt added together to actually get what we call as the double decomposition to produce a certain type of salt, which is insoluble. Okay. So diagram A shows an experiment to determine the heat of precipitation, which of the following mixtures obtains the results. So do we have, let's take a look at this. If you have silver nitrate plus sodium chloride, you should be able to get an insoluble salt for sure, right? Because you'll form silver chloride. So then after the second one, also same thing, lead nitrate plus potassium sulfate. Lead sulfate is actually insoluble. The last one, the third one will be barium sulfate is being formed, and the last one will be again lead iodide. So which of the following mixture obtains result as follow? Okay, you have to choose something which can release out heat. I think in this case here for number 39, the answer should be donkey lah. Okay, between nitrate and between lead to nitrate and also potassium iodide to form lead iodide. So that is because all the volume will get constant, right? So the only one that's exothermic in this case here, because there's an increased temperature over here. So it's basically donkey. And the last question, number 40. Diagram 9 shows the structure of the polymer. What is the polymer and the polymerization process that it produces it? So 2 different structures. not the same anymore. So therefore, this is not addition polymerization, not addition polymerization. Why? If it's two different molecules, it's usually condensation polymerization with the removal of something else. So you see over here, what is this polymer and the polymerization process that it produces this? You must look out for a particular substance which have, all right, two different structures. So the only possible answer here will be polyester, because there will be one, there will be two substances, one which is one has this particular one has a particular alcohol and one is a particular carboxylic acid. So combined together, there are two different structures, we'll see. So polyester is the best answer in this case, because got one alcohol, one represent alcohol, and the other one will be a carboxylic acid. So therefore, the answer is a polyester. So I think that's all for this particular paper. I hope you guys have learned something to prepare yourself for your exams. So that's all for me today, guys. Hope you guys will see you guys in the next video. Thanks, guys.